All right, hopefully, my Algebra 2 people, we are going to do some examples that help you learn on this exponential packet right here where we're rewriting the logs as sums or differences and then going backwards. So that's kind of what we're going to work with right here. Let me show you something real quick. If you were going to do this, I'm just going to show you something that works with numbers, and then we're going to throw in variables, and I'll show you that it indeed works. But also, remember when you take the log of something, you're getting an exponent. And do you remember the rule, like if I have x to the third times x to the fourth, what you can do with your exponents? Yeah, you can add them. So that would be x to the seventh. So when you multiply and you have the same base, you can add your exponents. So I want you to show you something here. First of all, this right here equals 5. And the reason this equals 5 is because 3 to the 5th is 243. You could also hit this in your calculator, the log of 243 divided by the log of 3, and test me on that. Okay, but this is 5. And let me write here, just in case you're still confused, I'll tell you why. It's because 3 to the 5th is 243. That's why. Okay, so when you take the log of something, you get the exponent. Notice that is the exponent on this. Okay, so I want to show you some really cool trick. If you were not going to use a calculator because you didn't have access to it, I might think of two things that would give me 243, and I'm just telling you 27 times 9 is. Now, here's where that lovely rule comes in, where if you're multiplying and you have the same base, you can add your exponents. And remember, when you take the log of something, it is an exponent. So what I can do is I can split this up and add them. So notice, I'm going to back this up just a little bit. I would still have log base 3 of 27, because this is an exponent, plus log base 3 of 9. Well, I know this is 3. Why? Because 3 to the third is 27. And I know this is 2. Why? Because 3 to the second equals 9. So I still get 5. So either way it works. Now what I'm showing you here, you're going to be like, who cares? I'm showing you a property right here so that when you get ready to do something like, I'm looking at it, number 46 right here, and it wants you to, says right here, expand into sums and or differences. I could rewrite this. And by the way, let me just say, you don't even see the base here. So if you don't see the base, do you remember what it is? That's what your calculator likes right there, is base 10. Okay, so I could rewrite this as, this is the same thing as log of 2 plus the log of x. So I can split these up. Since you're multiplying, I can split them up into 2 by adding them. Okay, notice I had to write the log twice. So that gives you a little example right there for that one. Now, let's do something else, because we're going to do a whole bunch of these. Remember, I'm going to do this whole same thing here. If I had x to the 10th over x to the, I don't know, 4th, when you divide, do you remember you subtract your exponents? So that's kind of cool. So we're going to do the same thing right here. I said, right here, I'm dividing, and I'm like, ew, that looks really gross. But by the way, 625 divided by 125 is 5. And I know the log base 5 of 5 is 1. Okay, why? Because 5 to the first is 5. And remember, when these are the same, it always equals 1. Love that little property if you can remember it. Okay, so this property says that if I'm dividing, okay, I can split it up by subtracting them. So let me go ahead and write this like this. So I would take the 1 on the top, log base 5 is 625, minus the log base 5 of 125. Okay, because remember, when you divide, you can subtract your exponents. And when you take the log of something, it's an exponent. I keep saying that because I want you to be sure. This right here is 4. Why? Because 5 to the 4th is 625. And this one right here is 3. Why? Because 5 to the 3rd is 125. And notice you get 1. Now, I'm just showing you that this lovely property works. Okay? So let's do number 44 real quick from your book. It says, or from your packet, log base 3 of x over 5. And it wants you to rewrite this as a sum or differences, which means a subtract of logarithms. So I could write this log base 3 of x, and since I'm dividing, I can expand by subtracting log base 3 of 5. Make sure you don't forget to write your little base right here. I didn't have to earlier on number 46 because it had a base of 10, and you don't even have to worry about it. Okay, let's look at 48. 48 looks like this, log base 5 of x to the 4th. Now, this is a property we already went over last time, but this exponent, you can swing him out front. So honestly, all they want you to do is rewrite this 4 log base 5 of x. And that's it. That one's pretty easy, okay? 50, I love 50. 50 looks like this, log base 4 of AB over C. And they want you to expand it. Okay, notice I have 1, 2, 3 things, so I'm gonna have to break this up into 3. So it's gonna be log base 4 of A. I'm multiplying up here, A times B, so I can expand by adding log base 4 of B, but then I'm dividing by C. So I know that I would have to subtract log base 4 of C, and that's it, right there. So it looks kind of weird. All right, now let's try another one. 52, I love 52, it gets really interesting, but we've got log, and I think that's a B, that's what I get for getting old, of the square root of xy all over z to the 3rd w. Okay, this one's great. Okay, if you can do this one, you can do about anything. So I'm multiplying right here. So I'm gonna write log base b. Now listen, I could write the square root of x, but instead of writing the square root of x, I'm going to write x to the 1/2, because remember that's the exact same thing, but I'm going to rewrite it with exponents. Plus, because I'm multiplying, log base b of y. Now here's where you got to be careful. I am dividing by both of these, so I am going to subtract log base b of z to the 3rd, but I'm also dividing by w, so I also need to subtract log base b of w. Now I know that confuses some people, but I want you to think about this. You are dividing by all of this. So one thing you could have done is right here, you could have, some people put a little plus sign in here because you're multiplying, and you can do that, but then that would have to be in parentheses because you're dividing by all of this. And then you would eventually distribute that minus sign in anyway. So this is what you'd end up with. Now this is perfect, but I want you to take it one step further. And if you have an exponent, I want you to go ahead and bring it out front. So your final answer should look like 1/2 log base b of x plus log base b of y minus 3 log base b of z minus log base b of w. That right there is your answer, okay? So let me see if I can find one more that's really crazy wicked. Let me get another piece of paper right here. Yeah. Okay, sorry about that. All right. I would say 54 could be a little tricky because I see a plus sign mixed in. So let's look at that one. It says this, log base 2, and it's got an x plus 1 in the numerator, and a y squared square root of z in the denominator. Okay, let me just say, remember when there's a plus or minus, that this is like a groupie dude, okay? And so he has to stay together. Our rule is when you're multiplying, you can split them up. You cannot split it up if there's a plus or minus sign. So the way you would write this is log base 2 and put him in parentheses, okay? Because he belongs together, just like that. Now you're dividing by this guy. So I would do log base 2, and look, I can see, I'm going to do 2 steps in one. This would be y squared, but I'm going to go ahead and I'm going to bring this 2 out front. So it should be like that. Okay, hopefully it wasn't too much. And this, I'm also in the denominator, so it's going to be log, what's my base? Z, or is that a 2? I'm trying to look. It's a 2. Let me make my little fancy 2. Okay, of z to the 1/2, okay, because the square root of z is the same thing as z to 1/2, but I would probably do all 2 steps at once and bring that 1/2 right out front, okay, so it looked just like that, okay, so that would be that one. Okay, let's try one other one. Let's try number 50. Ooh, 56 is good, but I like 58 too. I might let you try 58 on your own. But be careful because I see, look at here, on 58, when you do like the log of 1, and hopefully they've got another one like that because, oh my gosh, I really like him. Yeah, there's yours, 59. Think about it because it's going to simplify just a little further. Okay, but 56, oh, they're so fun, right? We get the log, we get a crazy cube root of a b squared over C. Now, let me just say that all of this, okay, I'm going to rewrite this right here. All of a b squared to the c, that's all to the 1/3. That's what it means when the whole thing is to the cube root. Just remember, like here, the square root was to the 1/2, but all of this is to the 1/3. So what you're going to have to think about here before you even expand is that my a is to the 1/3, my b squared is to the 1/3, and do you remember what you do with these? You multiply them. So you would have b to the 2/3 all over c to the 1/3. Okay, then expand it. Okay, and I'll just barely get started here, but this would be log, and it didn't tell me a base, so I'm assuming it's base 10, okay, of a to the 1/3, but I'm going to swing my 1/3 out front here, plus log of b to the 2/3, but I'm going to swing my exponent out here, minus, because I'm dividing, and it would be log, and I ran out of room, so I'm going to write down here, log of c to the 1/3, but I'm going to swing him out there. So it should look like that, okay? You could have written this as, you could have brought this 1/3 out to the front at the very beginning, okay? If you do that, which I actually think I might like that better, you would have got 1/3 way out at the front, and then split this up, and it would have been the log of a plus 2 log of b minus the log of c. So it's good to know that either one of these work, okay? Because if you were taking the ACT or something, you would need to know that this is the same thing as this. So they would work, okay? All right, so that's expanding. I will do another video where we are combining. So we will be taking this and going backwards.